Welcome to the solutions video for our reactor components labeling task as part of our lesson on nuclear fission. In this task you were given the image of a nuclear fission reactor and told to label the components that were indicated with various numbers. So make sure you've got that diagram in front of you. Either you've copied it down by drawing it, you've printed it off, or you've got the labels on there somewhere so that you can amend or correct or just tick your answers. So the first of the components, number one, were the long rods that were fully immersed inside the left-hand chamber. And those were the fuel rods. And they are made usually of uranium or plutonium. Typically, uranium is what you'll find in most reactors, but plutonium is also used as well. So they are the fuel rods. And that is where, if you like, the magic happens. That's where your fission reactions go ahead because they contain the actual fissile material. Now, number two were the actual similar shaped structures that were sticking out of the top of that left-hand chamber. So there were three that were fully immersed and three that stuck out the top. And the ones stuck out at the top were the control rods. And you might remember that I mentioned this, don't know if I wrote it down, they were made of boron because those are the rods that are inserted between the fuel rods. So if there's your fuel rods, your control rods are inserted in between and they stop the reactor by absorbing the neutrons, meaning that the reaction either slows down or if you put them all the way in, stops entirely. Now, number three and number four were actually labelled together. So these two answers can be taken in either order because they are referring to the same component. They are interchangeable. And they are the coolant and the moderator. So the coolant is what keeps the fuel rods from overheating and causing a meltdown, whilst the moderator slows down the neutrons in order to make them better at causing fission rather than them being too fast for one to happen. And in both cases, in this reactor, that is water. There are other reactors out there, and I think I did make mention of them in the main video, that would use different moderators. So for example, carbon dioxide is sometimes used as a coolant because these are gas reactors rather than liquid reactors, whereas the moderator, you'll sometimes find solid graphite used. So sort of as an option, you might find graphite as a moderator and CO2 as a moderator, but in typical reactors that you'll see labelled in most diagrams, it will be water for both of them. And as I mentioned, you can switch these two around because it pointed to the same component. Number five is the bit at the top that had that little fan symbol, and that was probably one of the trickier ones to get, the heat exchanger. Like I tried to act this one out in the main lesson, but it's very tricky without seeing it. So the heat exchanger takes the hot water from the reactor chamber, sends it off to this secondary tank, and that hot water is used to heat up the second water pipe, and then that water that gets hot is sent off to the turbines as it's turned into steam, which is very, very useful. In fact, it's usually steam that goes out the top, round there, turns that water into steam, that steam then condenses and goes back into the reactor. So it's actually even cleverer than that. Number six was the main structure on the left-hand side, and that was labelled as the reactor core, which was the big steel structure that surrounds the fuel rods, the control rods, and the moderator slash coolant. So all the stuff on the left-hand side was contained in that one vessel, and that was the reactor core, which is where obviously all the reactions happen, predominantly, of course, within the fuel rods. And number seven referred to that structure around the outside, which was our concrete shield. I made mention of this in the main lesson video because there's a lot of radiation and radioactive materials left over from the initial fission. So you've got some radioactive isotopes left behind, your water is irradiated, and there is a chance that, particularly with gamma radiation, that can get out of your reactor core and go on to be a problem. So we have the concrete shield, which wraps all that up and means that any leaks of radiation from the reactor core are contained, and there is no problems in terms of a radiation leak from the wider system, which is brilliant because we don't want any trouble. So those are your answers. I should really change this jacket because it keeps writing over my answers. Moderator, water. Yeah, I might change a jacket for the next lesson video. So there you go, those are the solutions. Fuel rods, control rods, coolant and moderator interchangeably, heat exchanger, reactor core, and the concrete shield. Add to your diagram if you need to, make any corrections, or just tick off your answers and then stick it into any notes you're working on. When you're happy, return to the main lesson video by the link in the description.